Hey guys, back in the garage. Today I'm looking at alternative propulsion methods for the Radical rocket. An idea I had some time ago was a hybrid electric ramjet engine. So essentially what we do is we're taking a ramjet of sorts and we are putting an electric ducted fan in front of that, and then the idea is that the airflow through, we use that, we add fuel to it, we get combustion, we get a whole bunch of thrust out of the back. Now, the way conventional ramjets work is they require supersonic speeds. So the combustor I'm going to base on a gas turbine. Now, if you're not familiar with how a gas turbine works, I will do a very, very basic sketch. So don't criticize me for, this is just the principles, the very basic principles, okay? So it's not entirely accurate. So what you have is you have a compressor fan, this over here, so the air's coming in here, okay, and then you have a shaft, and that's connected to a little turbine on the end. Now inside here, okay, imagine this is a ring, donut, okay, and you've got your drive shaft through here with your bearings and such, and then you have some airflow around here, some airflow around here, and then in your combustion chamber, which looks kind of like this, yeah, you've got holes around the outside, okay, which are around the outside of your tube, okay. So the idea is the air comes in, the air goes inside the combustion chamber, okay. This back bit's open here, all right. The air goes inside the combustion chamber, and then it gets ignited, and then the expanding gases come out of the back through here and spin this turbine up. Now, because they're spinning this turbine is connected to this compressor, so the more gas pressure that comes out the back, the more air is forced into the combustion chamber, okay? So that's how a gas turbine works. Now, the great thing about that is it's kind of like self-fulfilling. So the more pressure that gases that come out the back, the more the compressor is turned, and you don't have an issue with combustible gases pushing the air back, because there's always this kind of connected system. Now, what we're doing, and what I'm proposing, is what we do is we have a here's your tube, okay, and we have our electric ducted fan at the beginning here at the start. Air's getting sucked in, it's coming in through our tube. And then what we do is we have a combustion chamber. It's got our holes in, all right? And then we've got our injector and we've got our spark plug. And then the air comes in and it goes in through the holes, okay? And then the fuel gets sprayed in, it gets ignited, and then our gases come out the back, okay? Now, what I'm not sure about is, first of all, is there sufficient pressure generated by the ducted fan to get combustion in the chamber? And the other thing is, will the pressure inside the combustion chamber be pushing against the airflow of the fan? So as the thrust increases, and therefore the pressure pushing back on the fan increases, does that increase the load of the fan? In other words, do we get no net gains? Because the more thrust we have in the combustion chamber, the more the fan has to work, and therefore we may as well just use the fan in the first place. We may actually not gain anything at all. So that's what I want to test. So I'm going to build an electric hybrid ramjet engine, I guess that's what it is. See if it works. so I've taken the 5-inch exhaust and I've added the 5-inch to 4-inch reducer. I've taken a section of the 4-inch tube and I've added the two 4-inch to 3-inch reducers, and I've taken a flat piece of stainless and put it on the end. So I've got a hole in the middle for my injector, which I'm going to widen out, and so I'm going to weld an M10, fine pitch M10 nut on there, and I've got a series of holes around there. I've also got some larger holes here and then larger holes again there. I think I'm going to need more holes. I need to try and do a best guess on the calculations. And then the idea is this one is going to go down inside here, so that as the reducer, as it comes in with the reducer, it's going to be pushing the air into these larger holes here. So that's going inside there like this, and then you've got your combustion chamber in there, and then the ducted fan's going to go on here. You're going to have a hole on the side for the spark plug and another hole on the side for the fuel line, which is going to come in and then turn through 90 degrees and then go in the end of the combustor. I'm going to use copper brake line for that because that's easy to work with. I'm probably going to run it on butane first of all, see how that works. So yeah, so those are the parts made from standard off-the-shelf exhaust, stainless steel exhaust parts. A little bit of welding, a little bit of grinding. So this is the end of part 1 of the hybrid electric Ramjet engine. As you can see, I've tested the combustion chamber, the fueling and the ignition. That all works perfectly. The motor that I'm using on this one with this particular fan has got a 6mm shaft. It's a bit of an error on my part when I ordered it, because the actual fan requires an 8mm shaft. So I've ordered a little collet adapter. As soon as that gets here, we'll be able to get the fan on the front, get some air pushed through and see if we can get combustion. So super excited about that. Thanks for watching and see you guys in the next video.